Welcome, everybody, to another episode of Quack and Code, where we do quack and code. And today we're going to talk about table format. And I know I've been there for a couple of meetups. Table format still sounds a bit weird. A lot of people are, kind of understanding what's a file format, but what are the table formats? And when you hear some names like Hudi, Delta Lake, or Iceberg, which are going to be the topic of today, then they start to ring a bell. But what are the exactly added value of them and what's behind the hood of this table format? We'll dive into this. And we're also going to get into a pragmatic hands-on where you can read and write, hopefully, we'll see, with DuckDB and Iceberg. But for that, of course, I welcome the expert on that topic, on Iceberg topic, Brian, which is with me. Brian, how are you doing? Welcome.
Hey, Mehdi, how's it going? Thanks for having me on. And yeah, I'm doing great. How are you doing?
Yeah, we're doing super great. I mean, it's summer now over there. Um,
Yeah.
but let me just check that we are correctly live.
Okay.
It seems that just checking here, and I think
Yeah, got to make sure the audience can actually see and hear
if
us.
you're with us here, please let us know. But yeah, we are live on both sides. LinkedIn is not being LinkedIn on streaming. It does work sometimes, but yeah. So what's all about those table formats, Brian? But before that, who
Sure.
actually are you, and what is Tabular as a company itself?
Yeah. So that's a lot of good questions. I am a kind of I like to start off U.S. military background that got me really interested in technology and databases in general. And from there, I decided, well, I should just, learn more about how a lot of this satellite communication database type stuff works. So I did an undergrad in computer science, moved from there into getting into data type space still. At that time, Hadoop was just becoming a thing. And I was, in fact, doing research papers where all we did was talk about Hadoop ways of doing traditional things, and how to do it in a distributed manner, which was very new and exciting. And then after that, got I followed on to do my master's and then got a job as a basically data engineer. I was still software engineer at the time, but data engineer shortly came after, and I just never changed my title. So really diving into a lot of these weird issues with like Hive and all this stuff, and seeing like you would have I started out in Trino, actually, working a little bit in Trino, and one of the hilarious kind of quotes that one of the Trino creators, Martin Traverso, would always or kind of spout out and when they were initially creating Trino and making the initial stuff was, yeah, it's a good day whenever you can get like 6 queries run in Hive, and that's
I'm
that's a
curious.
good
Is it
day.
is it is it because of the technical challenge or the query language?
This was, in the early days when we were first trying to handle distributed data sets, done at this very high scale and done in a fault tolerant manner. The issue was, you were scaling up to a certain number of data, and you're ultimately going to, go through these large computations. At some point, if you have a single, kind of area of failure, you don't have a way to like get that original time back. You don't have a way to recover in a way that you don't have to start back from square one.
Yeah.
And so that was a really big focus on Hadoop and all these other things, is fault tolerance. And so fault tolerance came at the heavy cost of actual usability. First, in that there was really no SQL type way to actually access this data. You would have to write MapReduce programs.
Yeah.
You'd have to hire these people to write Java, and it was or Python, and it was terrible. It was very, very poor user experience, not very well thought through. But what this was really only doing was saying, hey, it's possible to evaluate data at this scale now, and look, this is what everybody's doing. As you know, Mother Duck has pointed out, it's not that everybody really needs to have this size and scale of data, but at the time it was very much like, oh, everything is going to be big data. You need to be able to understand so many different data formats to function in this world, and so everybody jumped into the bandwagon without even asking questions.
Yeah.
And then you get into Hive, which is the SQL kind of layer that sat on top of this thing. And it's trying to kind of get us back to the feeling of like, oh, yeah, this is a SQL database. But we had kind of violated a lot of the expectations that you would have from a warehouse. It violated a lot of the speed, of course, but we particularly did not have any like particular guarantees in terms of how updates occur. If you're dealing with a warehouse, sometimes you're just doing append only, and that's fine. But sometimes you actually do care about kind of like those ACID properties that we would have in an OLTP type data system. And so, warehouses were always able to handle this. The idea was that it wasn't going to be super frequent, but when it does happen, I need to make sure that I don't duplicate records, or else I'm going to have inaccurate results in my analytics. So, so that was another kind of big aspect outside of just the user. Incredibly poor. It was an incredibly poor kind of experience from the from the actual end result. The analytics that came out of that may or may not be correct. So that obviously took some time. People were still kind of saying, well, we need to still be able to process this data. We're just going to have to assume or take kind of assumptions that, well, the data is not going to be perfect, but it's going to be in the ballpark. And that was kind of the general running assumption for like almost 10 years after big data really took off. And so, get some ballpark answers, not perfect answers, and, live with it. Over time, we start kind of see this unfolding of, well, no, if I'm in financial data, right? If I'm in the fintech or something like that, it's incredibly important that the data is actually correct. So basically I need, my cake and I need to eat it too. I really need to be able to, have this analytics warehouse type setup. And I can't give up the quality of the data. I can't give up all this stuff, because I need to actually ask real questions on this that need precision. And so all the requirements like ACID and all these things started to come creeping back into our vernacular and an area of concerns for users. So, Hive had constructed basically this, I don't want to call it a spec, because a spec requires you to write something down. You effectively to understand how it works. It stores a bunch of metadata around these SQL tables or Hive SQL tables, and with that, you'll be able to retrieve all of that from a catalog, which is going to be stored in a centralized little, MySQL or Postgres database on the side, and that's going to track all of my table information. If you look at any regular database, you look at the information underscore schema database, that's giving you all the metadata about any table that you've created in that database. This is pretty much where all of that data is getting stored, and then you'll have like HDFS, which more frequently over time became an S3 object storage layer that you would just, you dump the actual data into. So to initially address like these, kind of ACID requirements, people started using HDFS and S3 and different file systems as the mechanism to basically do a compare and swap.
So let's
compare and swap.
Yeah, let's unpack because
sorry.
there is already that's great, but there is already a lot, right? So we came from basically Hadoop era where we need to distribute the compute, right? So we're getting out of the data warehouse SQL, simple SQL, right, approach, and we need to dig to deal with a lot of different technology, MapReduce and Java developers and so on. Yeah. But we lost a lot of features that we had from the data warehouse. And Hive is kind of the premise where they store metadata on the object storage. So back then on the HDFS, and then now on S3. And so far we're trying to understand basically, where those table format is coming from, and that's the timeline, right? And we are getting. Yep. So what's the next step basically after this? So we have Hive running with some metadata, right? Yeah. But we're still relying which kind of file format is mostly popular at that point of time.
Yeah. So one actually brings up a good point. So at that time, right, like Hive was interacting with these files that would actually get stored on object storage in HDFS, and started out with row columnar, eventually moved into ORC and all these other things, and eventually we get to what we commonly use today, Parquet, in terms of a binary format. And obviously you still use JSON and CSV and all the other pieces, but if you want to have a performant system that, especially on columnar or SQL data, tabular type data, you'll ultimately want to have that in a binary format like a ORC or Parquet. And so those are file formats. So think about those synonymously with like JSON or Avro. Avro is another one of those that isn't quite the same. It's more row focused and not going to be as performant. But the goal is like there's going to be some level of metadata that gets stored with some of these things. So you have JSON or something else, like, JSON has the title, the titles of the thing, and maybe a CSV file might have the title of the header row. Yeah. And that's some data about the data, but that's kind of usually where it ends for those more plain text format.
Parquet is also typed, right? So there is a schema.
Exactly. And so Parquet has kind of this nested schema and has a lot of information in the footer itself about how to find data within the file itself. So you don't have to scan the entire file depending on what you know about what you're looking for. And so these file formats had existed from like the Hive days, like those kind of were built out of Hive time. So Hive was, able to do some of this and kind of replicate the look and feel of this. But as we mentioned, like performance was terrible. And we also didn't have any true concept of atomicity, because getting back to some ACID stuff, I know this is getting kind of down to boring, maybe school time education for people, but atomicity, you need to basically have, a kind of compare and swap ability to, particularly when you're implementing a framework called like optimistic concurrency. And so effectively, two writers, everything, again, we're distributing, we're trying to do things in parallel. Two writers that are trying to add data to a table at the same time, and ultimately have this shared resource, right, that they're trying to write to. One's going to finish first and commit and be the winner, and then there's going to be a second one that tries based on the older state, and we got to make sure that one fails. Well, a lot of times this was being used at the file system layer to do this compare and swap, and there's the file system itself, this would be, they would utilize like a file being written as the kind of way to see if there was a new commit. And there are plenty of ways where that's not an atomic operation. In fact, because it's a distributed system, you have to write it, and depending on which node you're reading from, you might get a different answer back.
Yeah, and those features are available in data warehouse, right? In classic SQL database.
It was kind of pseudo ACID stuff, and provided you don't get into that, one case, various cases where you're dependent on this thing to be an atomic operation, and it ultimately isn't, and fails you to, you'll have duplicate records, you have data that's broken and could actually cause corruption in the data itself.
And what's the timeline again? Like here we're talking about like roughly 10 years ago, right? On average. So, like
what is it? 2014, 2024? It's about 10 years ago.
Right. About a decade ago. I mean, people were starting to move to cloud and so on, but on average, like if you were doing a distributed system, like Spark was still pretty new. And so Parquet started to kind of raise because of Spark, I guess. What's your thought on that?
I don't know. I think I think it's just the network effect you get with certain things adopting, right? So Spark obviously had a lot of good support there. But for instance, Trino started out with heavy orc support, and then later had to move closer to Parquet because of the network effect. So I think I think Pandas also had a lot to do with that, because they had primarily Parquet support.
Yeah.
And that's when you started getting more people on. You had kind of the data engineer, type of person, and then you had the kind of data science person, and everybody was seeing Parquet, because I think particularly there was one feature that people really loved, which was the nested. You could do nested structs and things like that, whereas Orc didn't have. You could technically do it, but it wasn't like supported from a indexing type way. So people went to Parquet because, well, real data in the real world is nested commonly, and so especially if you're trying to avoid joins. So then okay, well, we have this thing that doesn't actually give us full warehouse features. It's really slow. So, we bring in engines like Spark and engines like Trino to speed it up in different ways, and handle edge cases and use cases to make that experience better, which is good. There's a lot of cool user experience pieces that come out of the PySpark area, analytics in terms of like making things interactively set up so that your BI person or anybody can kind of not have to wait, and only run 6 queries a day.
Yeah.
It's quite a business killer if that's your speed that you're running at. And so, so this ultimately, speeds some things some of the way up, but we're still missing a lot. And so next around, I'm gonna totally botch the dates on this, but
I can help.
Maybe data. Do you know when Databricks folks started to open source Delta Lake?
Ooh,
I'm trying to remember is it 2015?
Open source it? I'm not sure. I think it came later than that, because they started working Delta Lake internally, and then they open source it. But that would be like 17, something like that. I would say later than that. Yeah.
In my memory, they were the first ones on the scene.
Yeah.
Shortly after Hudi comes out of Uber.
Yeah.
And so Databricks is basically open sourcing their version of what's basically going to be replacing Hive's couple things. You need to be able to replace the mechanisms for ACID capabilities and make that actually work.
Yeah.
Unfortunately, they initially they were still doing, and this actually just recently changed. They were still relying on the file system for a lot of that, and still not being atomic in all cases. But over time, right, then they've recently, I think, just updated that feature. But to have an external catalog out of simplicity, it's not fun to have to run an external catalog, but this is one of the advantages.
Now maybe we can as we dive into the table format, right? And first,
yes.
maybe we can dive directly in Iceberg and coming back to the timeline to say what
Yeah.
requires a table format usually. So you already mentioned, a catalog. Um,
Yes.
and maybe we can grab the picture you mentioned.
Yeah. Let me go ahead and share my screen then. A quick, we'll get back to how these connect. But essentially these three things come out, and it's kind of, we actually wrote down, the things that we're tracking and that we need to understand to know about a table, and actually, have a shared consensus of what that actually means, versus in Hive, it was kind of anybody's guess and reverse engineering, things. And so,
Yeah.
so this is, the last person on the last project on the scene was Iceberg. I think coming around in 2017 out of Netflix, 2017, 2018, maybe 2018 was the official open sourcing, and donation to Apache. So it comes out, it goes in incubator status, and then it basically goes right into kind of the public use. And at first people were like, another one.
Yeah, because so far,
Um,
like if we keep the timeline with us as we started with like this, we had Delta Lake, then
yes.
Hudi
Yeah.
from Uber, and then Iceberg from Netflix.
Yeah.
It's kind of funny. Do you have any comment on that? Like we have two table format coming from tech company, and then like one coming from a
Yeah.
data company. What's your thought on that? Can we?
So between all of them, Delta was the first. So obviously, like they were just, kind of exposing how they solved their problem to the space. And I don't actually know maybe more of the specific reasons, but I think there was an idea to get maybe community more involved in that, because they do build around the open source community pretty well. So I think they were just the first trying to do this warehouse thing and sharing the ideas there. It didn't work. So Uber's case, they have real time streaming ingestion cases, and so there is various trade-offs that come into how you bring data into a data warehouse, and effectively trying to treat it, instead of treating it like more of a centralized data repository, like a warehouse, you're trying to almost like use that generic data lake architecture to architect something like a ClickHouse, or like a streaming ingest system, where you immediately can do reads on data that's coming in. And this was critical obviously for a use case like Uber, because you got like time estimates and things like that about different cars moving around and people requesting at the same time, and you're needing to run those real-time analytics. It's incredible. I mean, say what you will about if you believe real time, where real time applies and where it doesn't. I believe there is plenty of applications, but I don't think that they dominate, especially when you think about the analytics realm. Real time is not necessarily like so ubiquitous that it's going to replace the kind of incumbent warehouse batch type workload. I think there are some companies who do have that need, and Uber is definitely one of them. And so Hudi was designed to basically be the data warehouse slash the master of warehouses and streaming ingest. And there came a lot of like trade-offs that went into that, and basically kind of maybe making some of the data consistency and data quality worse in favor of trying to support this this use case.
And so Hudi has deep streaming need, right? So they build their own table format based on that. But what about Netflix?
So Netflix then came in and were like, well, at the core problem, I think Ryan Blue, and he's the creator of Iceberg, also CEO of Tabular, and we can get into that later. So Ryan was an engineer. He had worked on Cloudera, worked on the Hive format and open source, and before he got into Netflix, and so he was pretty familiar with the problem space, and probably, I guess, I already had some theories going on in terms of how to address those, and they ran into that same issue again, and just realized that where Delta Lake was, and where around how they were still utilizing the file system as a means to handle that compare and swap for atomicity and all these other things. Plus, there's just all of these kind of like kind of legacy issues that still came in from Hive. Hudi and Delta both really struggled with like like they wanted to have backwards compatibility, or almost like you can have your Hive thing and you can have us running on the same cluster, and not have to really change too much. But there were intrinsic issues with that based on the fact that like Hive was built on the assumption of running on HDFS and a contiguous file store versus random access object storage on the cloud. And so there needed to be a full redesign in terms of how you anticipated the data to be laid out, and the kind of storage technology that you would be using, and the new realities of cloud technology versus where we were in the early days of Hadoop. And so this is where you start to kind of see this formation coming out. So without getting too much like basically this is what they came up with at Netflix. You have this catalog, and so a catalog is basically at its core, it is the thing that is tracking the state, the kind of like find me the current state of this table, and at a given timestamp or something like that. And so this is two things. It's a compare and swap operation. So you need to have that for that atomicity, and it needs to be something that already has ACID principles. And so quite commonly, it will be a database, kind of a SQL database, and similar to like it was in Hive. And the other thing is, whereas, Hive, a lot of the metadata resided in that database, whereas here, this one only needs, let's not have all the data, metadata stored and like kind of like co-located in this one bottleneck of a single catalog. Instead, let's use this catalog for the very minimal things that we need it for. So one, as we said, was compare and swap for the kind of the optimistic concurrency guarantees around atomicity. And then the second part then comes into, okay, well, we need basically the top pointer of basically our current tree, which represents the current state of our table. And so so you have that catalog, it's doing those two primary things. And then you're going to then, instead of having all of this metadata about where the tables are and all these things that used to be stored in this central database, well, now instead of doing that, you can actually outsource the traversal of this tree to a query engine that understands Iceberg format. And so instead of that query engine having to constantly check back in with this catalog here, as was done in Hive, it can now basically get that top pointer with a 01, like as that first call, and then after that it knows all of the rest of the information. And as it traverses that tree, these are all files that sit inside of an object store like S3. And so
and what kind of file? It's important to mention on which kind of file.
Yeah, and we'll look into these, but the metadata file and the manifest list are all Avro files. Sorry, as well as the manifest file itself. So sorry, metadata file is JSON, manifest list and manifest file. We'll get into talking about what those are. These two are Avro at this level. So you have a JSON file. The metadata is basically where like point me to where all the things I need to find. So you would do a read out of that. And then based on the query, you might have some information in terms of a predicate that you need to push down, or that when I say predicate push down, right? So you say where city equals, I think we have this example here later, city equals Belgium, right? So if I have a whole bunch of data around cities, and I have that predicate, that tells me in the query engine that, hey, I'm going to read this manifest list that specifically would be the only one that would contain the Belgium Parquet file that I'm looking for. And so I'll pull on that list and do another O1 read from S3 to pull that manifest file. Now that file is going to hold a whole list of data files, and these data files are just Parquet, right? It's Parquet or Orc or whatever. And so you'll then go ahead and scan those data, or talk to the manifest file. It's going to tell you specifically which Parquet files you want. As opposed to Hive, what Hive would require you to do pretty much is you would have to assume that this is like HDFS block storage and actually scan over the entire directory list of all these files and check each one. You would literally have to pull the footer out of each one of these Parquet files to see if the data's in there or not.
Yeah. So let's take a bit of time to recap.
Sure.
Because there is a lot. So we have base file where the data is still org or Parquet. It's mostly often Parquet these days, right? Correct me if I'm wrong.
Yeah, it's pretty much Parquet.
But so Parquet, we cannot update a Parquet file, a one row file, right? If you need to update one row within a Parquet file, you need to rewrite the entire Parquet file, and you cannot do any deletes. So there is a couple of limitations where basically those metadata will help. They will tell you if there is a delete happening, this will happen into some of the metadata layer, right? To see which kind of delete throw it's been.
Yeah, you'll act, so in deletes in at least in V2, you'll actually add a new delete file, and then you'll compress that out later. But
so a couple of operations that Parquet doesn't support here. It's kind of a view. If we come back to data warehouse, compact the view, but you're talking about compaction. Well, what do you define as compaction basically?
So let's actually real quickly look at this picture and try to think about like the regular operations. So before there's this part of the tree over here, let's just try to cover your eyes and not see that right side. When you first write to something, and we'll show this in the example here, in the Python example here with DuckDB, I have this Iceberg catalog. In our case that we're going to be running, this is going to be a SQLite. And so it's going to point to a metadata file that's going to indicate, the schema and all this stuff. And the metadata file initially won't have any schema or anything involved, or sorry, it won't have any data involved in it directly, but or maybe let's just in this particular image, you could maybe consider this like a copy as or whatever, like basically a copy operation where you do have data in the very first snapshot. But quite commonly, if you just create a table and then insert, you'll have one where it has like no manifest list, and we'll see that here in a second. But after you do that first kind of move in there, this first snapshot and what we call this metadata file here correlates to what's called a snapshot in Iceberg. And so in the catalog, you will basically store a record that says this is the current state, this is the current snapshot that represents reality. And then, and that's going to give you a file location that's going to, in S3, that's going to point you to this file. And then from this file, you'll be able to look and find, the list of things that are added. And so in this case, whenever we're on snapshot 0 here, you'll notice that this manifest list points to these two manifest files, but not this third one, right?
Yeah.
So if you are, if in the very first insert, you're only talking to these data files, and these data files don't exist yet. Let's say then you'll go and write another more data, a second round of data to this table. Then you're going to write a second snapshot that's going to create this new manifest list that now points at all three. So now we actually have two states that we can hop back and forth between. We can actually look at this table state at snapshot 0, and we can actually look at the table state at snapshot 1. Both, kind of coexist, however long we want to keep them around, and that metadata, can be compacted. We could take these two snapshots and just make them the current snapshot. And what that effectively does is it gets rid of this tree. Let's say over time you delete some files, or you delete a partition or something like that, then eventually these manifest files and data files associated with it would also go away. And so you're kind of seeing this like kind of moving, kind of progressing set of snapshots that occur. And anytime a snapshot's happening, that's actually a commit. That's that optimistic concurrency. You have some writer doing some work to write the data, and it gets a commit into the catalog, because the catalog is the thing that guards us from going outside of the atomicity guarantees of ACID properties and things like that. This is where really Iceberg started to gain a lot of momentum and shine, was, and gain early adoption, was this ability to actually, have a system and a setup that not only gives you this, ACID transaction and things like that, but it intentionally broke a lot of the older kind of compatibilities with Hive, just so that it could do a much better job at being a table format that builds on our current day architectures in the cloud, right? With S3 storage and all these things. And so when you look at this, and where we're at today, there's still this kind of confusion around, well, which one do I choose and all that kind of stuff.
Yeah.
Ideally, obviously you see things like Xtable and all these things to try to combine these. The goal in my mind is we need to narrow it down to a single protocol, just like we have. And I showed you this earlier, just like with TCP/IP and all the protocol wars, right? We need to ultimately choose the one that is going to be serving the case of warehouses. And so, so that, this, I'm not trying to get on my like soapbox crusade thing, but ultimately, instead of trying to create another artificial layer, that kind of combines these, I would say for the most part, Iceberg and Delta, after Delta opened up 2.0 and further 3.0, they've caught up functionally very well with Iceberg, and there's just kind of one-offs here and there of different functions that each support. So it doesn't really make sense at this point to have those two. And Hudi has the streaming ingest thing, but it ultimately can lead very easily to corrupt data, and ultimately it's not the best user experience. It's kind of still stuck in those Hadoop Hive type ages. And so the question comes then into is like, really, most people kind of have come to accept, unless you have a streaming use case, you're just going to have to choose between one of the two. And usually the choice comes down to, do I, am I thinking about, kind of the future architecture? As this grew, right? More query engines started to, adopt Iceberg. And as that happens, right, there's this Metcalfe's law. As more things use you, this is the same thing happened with DuckDB. There's a lot building around DuckDB, right? And so it's a similar type of experience where you have all these things that depend on and integrate and work with. The more you have that, the stickier the product is, and the more value the product will bring for you. And so Iceberg is getting at its extreme point. I wrote a blog, kind of provocative intentionally on the title to say Iceberg won the table format war, because,
Yeah, I've read that one.
yeah. And it was at the time when Delta had announced that they would be providing some support for Iceberg, and sorry, I didn't mean to say Delta, I meant to say Databricks.
Yeah.
But and when and similarly, Snowflake had also done this, and so this is the only format that's you could get Snowflake and Databricks collectively using, because it's under Apache. It's has a lot of governance from Apple and AWS and a lot in Netflix and a lot of other companies, including Tabular.
Okay, let me stop you there, because you're taking too much your hat of DevRel at Tabular, but you did say a lot of things interesting. The first thing is you said that there is other initiative to have basically abstraction on those table formats, right? X and Delta as also, how is it called again? Databricks.
Unity, I think, is the.
So there is also a framework to abstract Delta Lake, Iceberg for you. But if you think so, like, it's already an abstraction, a table format.
Yes.
Right? Because I've had also, I mean, we're not going into that path, but I had a chat with people thinking we should have a new file format, right? The standard, because it's based on Parquet.
One to rule them all.
Yeah,
right?
exactly. So I think it's exactly that. We are always getting into that point. But I think something which is obvious to me is that in the data ecosystem, we have a lot of complexity in terms of tooling, in terms of integration. And I don't think building abstraction on top of abstraction is really future-proof, right? It can solve maybe like a migration process or something, right? If you're changing a technology. But on the long run, I don't think it's viable. The question I have for you, you mentioned regarding the context, coming back to the graph, basically, because we talk about the components. So we need a catalog. We have metadata file, manifest list, manifest file, and then we have the data itself, which can be Parquet or org. What are the other components that are linked to a table format to these days? So you mentioned the catalog. Where does usually the catalog live? What do you see? And what's the execution engine? You mentioned a couple of them. That's this guy actually gonna write those table format here, Iceberg.
Yeah. So one I guess kind of what am I trying to think? One pattern that I've seen pretty frequently across a couple of different open source things. I've seen it recently in I don't know if have you heard of Matrix, the communication platform that's trying to So these basically, the goal that I've seen in a lot of cases is building out a standard. That way, and that's the kind of entry point and focal point. What Iceberg, the project is aiming to do is maintain that standard in a neutrally governed way, and maintain almost the SDK or the API and the libraries to those, but try as hard as possible to avoid any implementation details around anything in particular that's official, Iceberg. There's reference implementations that different companies will own. We have, Tabular has one. There's another company called Gravitino, and if you just go onto GitHub and you search for Iceberg REST catalog, these are good reference implementations that follow the specification, and you yourself could write one by looking at one of these. Similar like how, you know, this matrix is a spec. It has some libraries or APIs that it officially owns. But there's like, I don't know, 20 different reference implementations of the actual server that you could run yourself. Different ones have different licenses, different ones have different support and activity. And so I'm seeing this trend, and it actually works super well in open source in general. But basically this is where you know, that Apache Iceberg comes in, is the catalog. There's no official Apache Iceberg catalog. Now, there's some debate about bringing a reference implementation into the Apache Iceberg so that people can kind of use something out of the box that is, you know, supported by the community. But the concern there is we don't want to end up in a state where we were with Hive, where we had 1 million libraries that supported everybody's unique use cases. Rather, you know, you have at the most, you'll have a very, very, very light reference implementation. And then if somebody has like a special, you know, monitoring thing, or has a special, you know, extra set of libraries, you can take that reference implementation, copy it over to your org or something like that, and build that out, and even share it yourself, right? Like it's all part of like building around that community, rather than having, you know, one implementation that just gets bloated.
Yeah.
And requires a lot of testing and focus and maintenance. Better to, you know, resolve, especially with open source resourcing, right?
Yeah.
Trying to keep people, you know, focused and sustainable and all that stuff. It's better to have the focus be on as few things as possible, unless it's like an absolute necessity.
So we have REST catalog or specification, for example, to build a catalog.
Yes.
We have existing catalog. What's the common one that you see on the cloud?
Hive Metastore.
Hive Metastore. But there is also like serverless. I mean, I would say like Glue.
Yes,
on AWS.
Glue's. Well, Glue, and by the way, Glue is like the AWS version of Hive Metastore.
Yeah.
But has different features, of course. Then you have SQL. There's generic SQL, and it will basically use SQL Alchemy.
Yeah.
So you could, you know, connect to various SQL drivers there. So if you have MySQL,
I will do that because the time is running. So we have. In a few minutes, I just want to close on the components. So we're gonna use the SQLite as the catalog, and then what's the writing engine typically that is being used?
So it's whatever query engine. This is, you know, kind of thinking about the flip side. So if you look at something like DuckDB, you can connect to, you know, local file systems and all these other potential systems that you can query from by, you know, integrations and things like that. This Iceberg looks at the world as in a flip side, right? All these different engines can talk to this one kind of layer of storage format. And this is why I say I compare this to TCP IP. You think of like a SQL query layer, you think of then the table format, file format, and then S3, right? Those are kind of like our general protocols. And in each layer, you kind of have Iceberg, for instance, can talk to multiple query engines, and DuckDB is of course one of those query engines, with currently with just the read support and no write support.
And so, but if we coming back to Netflix, for example, they were mostly using which kind of execution engine to write? Iceberg?
So writing was generally done through Spark, and then they also supported like a reading through Trino. And so that's a very, very common pattern with early adoption Iceberg, but it's exploded to where, you know, BigQuery, Redshift, Snowflake,
so data warehouse basically have some features of data lake where you can write table format Iceberg within some of those.
Yes. And the cool thing is, if you write in one, provided everything is talking, you know, following the spec, or basically utilizing those SDK libraries that are maintained in different languages, then whatever is actually implemented within the query engine itself is actually what level of support you have for Iceberg.
Yeah.
And so
and
ideally
usually what's kind of where the catalog is storing, we still have the limitation where today those data warehouse, they use internal catalog, or what do they typically use?
It depends. I'd say most commonly people are still migrating away from their, a lot of this is centered around big data. So, old Hive shops that are trying to upgrade and get to the latest thing. And so there's a lot of migration tools. By the way, everybody has migration tools between everything. Like Iceberg has migration tools between Hive, and this is why another reason why Xtable and the other one is like, it makes no sense, because there's already tools to manage these migrations. So anyways, let's go on to the code part of this quacking.
Yeah, let's go.
Too much quacking.
Yeah, too much quacking. So I have I can share my screen. I have so you be the driver, I'll be the newbie.
Okay. Okay, sounds great. Yeah.
So basically, I'm going to share quickly. We have some issue on the LinkedIn Live because LinkedIn is being LinkedIn, but I'm sharing it on YouTube, and I'll share on the comments. Give me a sec on the Mother Duck Live here, notebook. I'll put again in the description later if you want to catch up. But the point is, we are going to use Iceberg and DuckDB to show you what's possible. Can you give me a brief note about the difference between Iceberg and Iceberg?
So Iceberg is thinking about that as the spec. Iceberg is that API layer for Python. So this is basically, it's not aiming to be a query engine on itself. So like DuckDB is a full-blown query engine. We want DuckDB to use Iceberg or other people who implement a Python library. We want them to utilize that so that anytime there's a fix that happens in our library, you upgrade, that you'll get that fix automatically. And this is being focused on and built out by the people. So here you're pulling in, this CSV file and very similar DuckDB thing that I'm sure everybody knows, and into a.
Well, it's good to do a recap. We have Perfect Stranger that coming to the live stream to discover, but so here is I'm just running a DuckDB query, and what's beautiful is that I can query an S3 file with one line of code. Every dependency is built in. I don't need to install anything. And it's a public bucket, so there is nothing to do. And I'm converting it to a PyArrow table. So I'm going to run this, and I think I just need it. It's done. And so now I have my Py table. I think it's about hair quality. And so we see the schema, and we have some sample of data over there. I need to install Iceberg, obviously, and SQLite. Why do I have to install SQLite?
Why do I? Oh, you're asking me, yeah. My turn.
It's you, the expert, right?
Yes, that's right. So SQLite is ultimately going to be the catalog in this case. So you have some sort of SQL database, and so SQLite has all of the ACID capabilities. Even though it runs like a local file system, it has all of those neat features and that we expect. I mean, at least it works on our Android phones, doesn't it?
Yeah. So that will be our catalog for the demo. And here I'm just creating a folder here. So this is my space, and I'm gonna do. So what does this part do? It's connect to the catalog, to the SQLite, and what's
so
this reference?
This is Iceberg. So it's talking to the warehouse. So this is going to be where we store the kind of underlying file structures. Generally, this would exist in S3. But because we're using SQL Catalog and because we're using a local file system, we're able to actually, fake out S3 and write it locally here inside of the notebook. So warehouse is pointing to a local file system. Usually it would be an S3 or whatever bucket, or HDFS, and then URI SQLite. That is pointing to so SQLite has a local an ability to write all of your SQL data to a local file system .db, and so that's where all of your SQL data, which is the catalog data, that holds that top level, what's the current snapshot that represents the state of the table.
Yeah, no, that's clear. And then here we create, I guess, a namespace within just the catalog, and we create.
So you're calling it default,
Yeah. I'm create a table which is in that namespace and air quality, which is my table. And so now,
and you're pulling the schema from the arrow to pass that along.
Yeah. So I pass the schema. So now we already have some metadata, which is appearing there, which is a JSON file.
So this file right here is a JSON file that directly correlates to a snapshot.
Yeah.
So any JSON metadata.json file is basically the in file version of a snapshot, and that's what the catalog, the SQL, if you query that SQLite database, it would point to this particular file, and then this file then points to nothing at this point because we have an empty table.
Yeah.
So
exactly. So now we're gonna do that. We're gonna append tables. So I'm getting basically the content of my pyro table. So p table is my source table initially, right? So I'm gonna run this, and here I should. So I do have some content. I need to refresh probably the file tree. There you go. So now we have metadata, and we have data.
Yes. So that you'll see that second metadata.json file. That's the second snapshot. And so now, in the same thing that we saw in that graph above, you'll have that second entry in the database, in the SQLite database, that points to that 01 snapshot file. That points to the first Avro file on the top. Sorry, the second one that starts with snap, and then from that Avro file points to the list the list file that actually points to then the Parquet file. It's a small data. Usually you'll have multiple data files, and a lot that this would make more sense in that context, but it's basically one file that points to another file that points to another file.
And so here what I'm going to do is just, we have a function to create a DuckDB table from that table, which is the Iceberg table. So this is where I'm doing the reading. If this works, I don't know if I lost my runtime, but it looks good. Okay. And here, basically, I'm just running based on, so this is just a DuckDB connection, and I'm running SQL command, and just from, because DuckDB is from statement first, I don't need the select star.
So above there, that scan operation is lazy. It just basically says, here's where you'll find the Iceberg table.
I see.
And then when you go to DuckDB and you say the table name, then that's, I like, connection, that Iceberg connection. Nothing's been executed until you actually materialize it to .SQL. And now you have in DuckDB, what it understands as the table air actually executes the full scan of the Iceberg table metadata at that point.
So there is no filtering happening there.
And so here, what so if you look at this table is actually the table, the Iceberg table.scan. And so this is when you see this row filter, this isn't actually being done in DuckDB. DuckDB currently only applies a full scan rather than pushing down something. So if you go down to the Mehdi, if you go down to that one, so this is actually just rebuilding the arrow data frame and then overriding the DuckDB table. So that you have less.
So there is no filtering happening at the read time. There is a transition to by arrow.
Yep. So if you were to update that SQL query, the from error and the DuckDB side, and you put where city equals Berlin, you would actually scan the entire data set without skipping anything, and that wouldn't happen. So I wanted to make that clear in terms of if you do ever point DuckDB to like some giant table right now, it would take a long time, and you'd be like, why the heck is this taking so long? And I'm hoping that we can encourage, if anybody's interested in, doing kind of messing with this stuff and playing around with this, and you're interested in this, please ask for it. I think we have some work that we would be interested in helping out in terms of contribution. And I do think there is some early PRs that have been kind of put forth to solve some of the push down capabilities that Iceberg can.
No, that's great. And so here, basically, what we do is simple, doing a filter within the arrow word, and then overwrite, as you said, the same data frame.
Yes.
So here's my new data frame. So now my state of my file represent basically these states, at least the last snapshot. So it's only filtering on the city Berlin. And so if I overwrite it to DuckDB, and I'm displaying again, I only have 10 rows now, and those contain only the Berlin city. So that's kind of like the good thing is that I really love actually the DuckDB Iceberg just to understand what's happening in local file, because it's true that it's pretty fast, right? Just within a notebook to explore step by step what's happening. And now we have another Parquet file, which is probably, and there is probably a diff happening. But one other thing maybe to mention is that, let me get my terminal one sec, that there is another way to read from DuckDB to Iceberg, right? And it's through the Iceberg extension. What's the actual difference between that and Iceberg? Do you know? I mean, the implementation is different, right?
So actually DuckDB does not use the Iceberg implementation. You're right. So in general, we kind of hope people would use, the centralized library, because that's the one that, the community supports. However, I mean, I think that Hans and a lot of the people on the core and Duck Labs and those things are very considerate and thoughtful in terms of, if we might write a generic library, but it may not be performant on DuckDB, and their big thing is performance. And so they basically have to re-implement everything that we've already implemented within Python. And it comes with trade-offs, right? Because then now you get to specifically make sure this runs optimal to whatever DuckDB's needs are. However, if there's a change or a fix or something that comes through our side, then you have to implement it there. So everything is a duplication of effort.
That's good.
Again, and it is managed by the Duck Labs folks, and Hans is open to this. But I talked to him when he came to Chicago a while back, and he's really wants to support this as the community needs it, or as somebody will pay Duck Labs money.
DuckDB Labs,
but DuckDB Labs, sorry.
No worries. So that's a really good point. So it's a different implementation. It's also a limitation to read support, right? And so how these work is that so here I'm in the DuckDB CLI. You can install Iceberg and then just load Iceberg, and I have I think this file. And so what I'm just doing is invoking a Iceberg scan, and there is a given file Iceberg table over there. It's taking a bit of time, but here we go. We have about 50,000 rows returned here for this one. But again, it's limited to read only, and it's a different implementation from from the Iceberg. So that leaves you two options to start at least your DuckDB and Iceberg journey. But what's we are already over time. But what's your closing thoughts about um, basically lighter engine or execution engine like DuckDB and table format? Where does you see it's placed against the other that we mentioned classically? Would it be Spark or a classic data warehouse?
Yeah, so I see a huge value in the developer experience of DuckDB and people utilizing it for various purposes around like local data engineering and local data science. And there's a huge value in starting out like at a smaller scale with the same data that you're actually needing to point to. And so, I a lot of times, people will mock data or point to various other things. I think it's incredibly valuable to provided you have access and you're it's good to do on your laptop. You pull this data locally, get a small representative data set of what real prod data is. And sometimes when you're doing that experimentation, it's incredibly valuable to point it directly to those tables. Like we said, having a full table scan is not ideal, and I think that DuckDB, is generally not necessarily aiming at the big data stuff usually, but I think when it comes to understanding and getting proof of concepts and getting the idea of what eventually gets applied at larger scale, DuckDB is invaluable in that process, and it's an incredibly important process that a lot of people overlook. So I see a lot of value, especially from the local developer workstation capabilities around big data. And even if it's like Iceberg doesn't have to be like big data all the time either. And so there is plenty of value in just having this mutually represented format that if you need to write test data or quickly spit out test data to an Iceberg table in production and then do a quick kind of sort of testing or validation, it's incredibly easy for DuckDB to see what the state is, and just knowing the metadata and using it for tooling in that sense, it's incredibly valuable. So all that being said, and particularly for me as a developer advocate, I care about it because
let's close that one by what's your plug around your position at Tabular, and yeah, basically what's your mission, and it's kind of like your plug, your ad time for the rest of
that's
it.
Yeah, that's exactly, what it is. It's I want people to understand table formats and how they differ from Parquet or other file formats, and I really want people to see the value of this, like of the things that we've solved. Basically making it possible for the warehouse to be at a large scale and still have the original data warehouse features and much further interoperable features across data engines, so you're not having to store data more than once. If you're in BigQuery or Snowflake or all these other things, you don't want to store that data multiple times. And so having a format that everybody reads and understands is incredibly valuable and important. And having it everywhere from DuckDB doing the local thing, working on that same format, to all the big data query engines that are doing this, it's incredibly valuable to have that and not have to move data around back and forth.
Yeah, no, I'm looking forward. Like that was one of my worst nightmares, data migration, especially between two different databases that has different type. So looking forward to not do that anymore.
Yes.
Thank you, Brian, again for joining
Thanks
us.
for having me, Mehdi.
It was a really history lesson. I didn't expect that. But I was pretty happy at the end. I did learn myself a couple of stuff. So thank you again for joining us. If you want to check Tabular, so it's tabular.io, and I'll put all the link in the description if you want to check by Iceberg. Yeah.
We also have a virtual book on getting started with Iceberg. It's Iceberg focused, not necessarily tabular focused.
Okay.
It's a virtual book that you can go look up on the internet. It's free. It's on Tabular's thing as well. I'll send you the link, Mehdi, so you can add it to the show notes or wherever you add it.
Good. Thank you. To that, see you next time into the Quack and Show, which is happening every other week. And I believe next time will be debugging SQL query. I think refactoring SQL queries. So that's an interesting one. Keeping like a long script. You've seen those one, right?
Yes.
Now, how do you tackle that? So that would be interesting. Stay
DBT.
tuned on. It's not only on DBT. I think in general. Just how do you handle that?
That's how I tackle it.
Don't spoil it. But not only that. But anyway, check out our event at modernduck.com/events if you don't want to miss another live stream. And yes, have a beautiful day, beautiful morning, or beautiful evening, depending on how you where you are, and see you next time.